So this is the video on the section 2 of unit 3. We're going to talk about how to find the measures of interior and exterior angles of triangles, and we're going to apply those theorems with interior and exterior angle triangles of triangles. These are some of our vocab words that I'm going to go over today in the lesson. So we're going to jump right in by talking about the triangle sum theorem. So I'm going to put some measures up here because I think you guys understand better when there are numbers. So we're just going to throw some numbers into this drawing. So let's say this one is 60, and this one is 70, and this one is 50. So when I add those three together, 60 plus 70 is 130, and 130 plus 50 is 180. So this would be the triangle sum theorem. When we add three angles together, we get that their sum is 180. And that's true every time we do it. I'm going to now show you why that's true. So I'm going to draw this auxiliary line, line L. And again, I'm going to give some measures here. So we're going to say this is 70, and this one is 60, and this one is 50. And the reason why those three added together equal 180 is because line L is a line and its measure is 180. Now I'm going to show you that these two are parallel. Now I want to talk to y'all about what is the measure of angle 1. So hopefully all of y'all can see that the measure of angle 1 and the measure of angle 4 are congruent because they are alternate interior angles. So that means this one is 70. Then we have that 3 is congruent with 5 for the same reason, because they're alternate interior angles. So this one is 50. So what I just did for y'all is I proved the triangle sum theorem. So the angles on the inside of that triangle, when I add them together, are 180 degrees. So example 1a, after an accident, the positions of cars are measured by law enforcement to investigate the collision. Use the diagram drawn from the information collected to find the measure of angle x, y, z. So angle x, y, z is x, y, z. So it's this angle up here. And notice that we have a triangle over here. And so we can use the triangle sum theorem to solve for the angle x, y, z. So the measure of angle x, y, z is 180 minus the other two angles. So we're going to do 62 plus 40. So that's going to be 180 minus 102. So the measure of angle x, y, z is equal to 72 degrees. And again, if we were to add all three angles together, they would equal 180. So we can take those two angles and subtract them from 180 to get our answer. So the next one says that we're now trying to find YWZ. So this one, we're looking for YWZ. So we're looking for this angle down here. And hopefully you guys can see in this drawing that these two angles right here form a linear pair. So we're going to do that to find the measure of this angle right here. We're going to find this one first, and then we're going to use that along with the 12-degree angle to find the measure of W. So we're going to do 180 again. We're going to subtract from it 62. That's 118. So that's what this measure is right here, 118. Once again, hopefully you can see that this is the triangle that we're talking about now. So we can add together the 12 and the 118 and subtract those from 180. So we're going to do 180 minus 118 plus 12. So that's going to be 180 minus 130. So the measure of angle YWZ is equal to 50 degrees. So I'd like you guys to go ahead and attempt to do this, check it out on your own, and then come back to me when you're done, and we'll go over it. Okay, so first of all, it says use the diagram to find the measure of angle MJK. So I realize that MJK, again, is this angle right here. So I only have one angle in that triangle, MJK. So I need to find another one. I do notice that I have a congruent symbol here. I have a congruent symbol here and here. And so I'm going to use this other triangle over here so I can find this angle. That's what I want to find. So if I can find this one, I can always find that one. So here we go again. So we've got 180 minus 88 plus 48. So that's going to be 180 minus 136. That's 44 degrees. So if this is 44 up here, then this down here is 44 degrees. Now you should be able to clearly see that we can find our third angle up there. So now to find the measure of angle MJK, we are going to do 180 minus our 104 plus our 44. So that's going to be 180 minus 148, and that's 32 degrees. So this angle right here is 32 degrees. So this next problem says to find the measure of JKL and JLK. So JKL is this angle right here. So I happen to notice that this is a straight line. So I could use that straight line to solve for that angle. So the measure of angle JKL is equal to 180 minus, again, I'm going to add those two together, the 104 plus the 44. That's going to be 180 minus 148. So this angle is equal to 32 degrees. So that's what this angle is, 32 degrees. Then again, we can solve for our last angle, which is this one up here, JKL. And we're going to do again the measure of angle JKL is equal to 180, and we're going to subtract those other two angles from it. So that's going to be 70 plus 32. So that's going to be 180 minus 102. So JKL is 72 degrees. So the next two concepts we're going to go over are called corollaries, and these are things that we can prove based on what we already know, and these are both based on the triangle sum theorem. So notice here that we have a 90-degree angle, so this is 90 right here. So that means that these two angles D and E, when I add them together, they have to equal 90 because 180 minus 90 is equal to 90. So those two angles D and E have to be complementary. Down here for the second one, this is an equal angular triangle. So that means I can divide 180 by 3, and that means each of these angles have to be 60 degrees. So we're going to do a couple of these problems now. So the first one says one of the acute angles in a right triangle measures 43 degrees, which is the measure of the other one. So I'm going to go ahead and draw this because some of y'all are visual, and I'm going to say this is 43 degrees. So again, because we've already used 90, we only have 90 left for the other two angles. So we're going to say 90 minus 43, and that's 47 degrees. And the reason why I didn't do 180 again is because I've already used 90 and I only have 90 left. Go ahead and do these next two check it outs, 2A and 2B, and then come back to me when you're done. So the measure of one of the acute angles in the right triangle, 63.7, what's the measure of the other acute angle? Again, when I add the two together, they equal 90. So I'm just going to subtract 63.7 from 90, and the answer is going to be 26.3 degrees. The next one says the measure of the acute angles in a right triangle are 3x and 6x. What is the measure of the acute angles? So on this one, we're just going to add all three together, the two together too, and set them equal to 90. So 3x plus 6x equals 90. So we got 9x equals 90. So x equals 10. Then we're just going to plug that 10 back in. So 3 times 10 is 30. 6 times 10 is 60. So our next concept has to do with interior angles and exterior angles. Okay, so interior is obviously the set of all points inside the figure, and exterior is the set of all points outside the figure. So interior is inside here, exterior is out here anywhere outside. An interior angle is formed when two sides of a triangle. So basically these interior angles are 1, 2, and 3. Exterior is out here, so an exterior angle again is formed by one side of the triangle, an extension of an adjacent side. So that's what this 4 is out here. So now when we talk about remote interior angles, we're talking about angles that are not adjacent to that exterior angle. So we call them remote because, again, they're not adjacent. So I'm going to give these, again, some measures so you guys can see. I'm going to say this one's 60 degrees and this one's 70 degrees. Now, if that's 60 and 70, when I add those two together, that's 130. That would mean that angle 3 is 50 degrees. Now, if angle 3 is 50 degrees and it forms a linear pair with angle 4, then we would subtract 50 from 180 to get that this is 130. Now, hopefully you can see that when I add 60 to 70, it is equal to 130. And that's why this is true. The remote interior angles added together equal the exterior angle. So we're going to go ahead and use this for now, this formula. And this is the same principle again, 1 plus 2 equals 4. Okay, so here we're going to say angle A plus angle B is equal to angle BCD. We're just going to substitute in those values. We're going to combine like terms on the left. Then we're going to subtract 2x from the left and the right. We're going to add 60 to the left and the right. So we get 78 is equal to 3x, divide both sides by 3. Now, look, be careful, because there's always going to be an answer on there that is this value of x, but we need to plug that x back in. So it's asking us up here for the measure of angle B, which is 2x plus 3. So we're going to say 2 times 26 plus 3, and that's 55 degrees. Now, the way we can check this is to go ahead and plug this 26 in right here as well. So that would be 5 times 26 minus 60. That would be 130 minus 60, which is 70. So we just found that this one was 55 degrees. Now the question is when I add 15 to 55, does that equal 70? And if the answer is yes, then we got the correct answer. So that's a great way for you guys to check and make sure that you got the correct answer. Go ahead and do this, check it out, and then come back to me when you're done. Okay, so here again, we're going to add angles A and B together, and we're going to set them equal to A, C, B. D, sorry. So we're going to add the 2z plus 1 and the 90. That's what we did over here, and we set it equal to the exterior angle. Again, combine some like terms. We're going to subtract 2z from both sides. We're going to add 9 to both sides. That's going to give us 4z is equal to 100. How many quarters make a dollar? That would be 4. So this is z is equal to 25. So then again, we're going to plug this back in. And again, it's asking us for A, C, D, which is this angle out here. So we're going to do 6 times 25, which is 150, minus 9, which is 141. Again, I want to check this. So we're going to do up here, we're going to go ahead and plug it in up here too. So that's going to be 2 times 25 plus 1. That's 51, right? And what is 51 plus 90? That's 141. And that's what it should be. That's a great way to check to make sure you got the correct answer. All right, our last theorem that we're going to go over today is the third angles theorem. So basically here, this tells us if two angles in one triangle are congruent to two angles in another triangle, then the triangles are congruent. Now let's play this out with some numbers here. So let's say this is 50 degrees here, and this is 60 degrees here. That would be 110. So that also means that this is 50 degrees over here, right? And that this is 60 degrees over here. So what does that mean about n? Well, 180 minus 110 is 70. This is a triangle sum theorem, right? Which means that's the same would have to be true of t over here. So this would also have to be 70 degrees. So again, the triangle sum theorem is what enables us to say this, but basically if we have two angles in one triangle that are congruent to two angles in another triangle, then the third angles have to be congruent. So looking up here, at this next one, we notice that G is congruent to H. Angle G is congruent to angle H here. We notice that F is congruent to I. So what does that tell us? That tells us that K, angle K, is congruent to angle J. So we are now going to write an equality statement here. We can say angle K is congruent to angle J. So the measure of angle K is equal to the measure of angle J. I'm going to go ahead and set those equal to each other. So we're going to subtract the 6y squared from the 4y squared. That's going to give us negative 2y squared is equal to negative 40. Then we're going to divide both sides by negative 2. So we can see now that y squared is equal to 20. Now I could take the square root of this, but there's no reason to. And the reason I say that is notice up here in the problem that y squared's right there and y squared's right there. So I can just sub that y squared back in there. So that's exactly what I'm going to do. And it's asking us for both k and j. So again, when I do 4 times 20, that's 80. And when I do, I could also do it here 6 times 6 times 20, that would be 120 minus 40 is also 80. Okay, so go ahead and do this last one and then come back to me when you're done. So here again, we have m is congruent to r, n is congruent to s, and we have that p is congruent to t. So we're going to, again, put this in a mathematical statement. Angle P is congruent to angle T. So the measure of angle P is equal to the measure of angle T. Then we're just going to substitute our values in. Going to get 2x squared minus 4x squared. Going to divide both sides by negative 2. Here again, x squared is equal to 16. So we can take this x squared and we can plug it right back up into the problem exactly the way it exists. 2 times 16 is 32. 4 times 16 is 64, minus 32 is 32 again. So